On to 11. Come on. You ought to be able to do 11. About do 11, about all you have to remember is I squared is -1. And you have to know how to FOIL. 8 times -2, -16. 8 times -3i minus 24i. -3i times -2 plus 6i. -3i times -3i is positive 9i squared. Now that -8i squared, let's see what's that at to, -18i, is going to be a -9 when everything is said and done. This will be -25 minus 18i. This is something you haven't done in a while. You're going to multiply the numerator and denominator by the conjugate. The conjugate of 8 minus I being 8 plus I. Then you're going to do the distributive property. 40 plus 5i up top. Down low, all that matters is first and last. 8 minus I squared, which by the way is a positive 1. So 40 plus 5i, both pieces over 9. You might see them break it apart. It would make sense that they would break the fraction apart. There you go. Oh, 13. Use the QF. Express the solution in standard form, whatever they mean by that. Let's see here. X equals -b plus or minus square root b squared minus 4ac all over 2a. Been a little sick. Sorry about the voice. It's just not its usual grandeur. Inside the radical looks like 9 minus 16 to me. 3 squared is 9. 4 times 2 times 1, 16. 9 minus 16 is -7. Sitting pretty over an 8. That's twice 4. Root of -7 is imaginary, so 3 plus or minus I root 7. Both pieces over an 8. How long that takes. Find the coordinates of the vertex for the parabola defined by the given quadratic equation. So, wow, this is something you hadn't done in a minute. Literally, the x coordinate of the vertex is opposite b over 2a. That's all she is. This would be -10 over twice of 5, which is -1. Since you have x, find y by plugging it in. The y coordinate of the vertex is going to be at 5. Whoops, wrong parentheses there. 5 -1 squared plus 10 -1s. I don't know why I used double set of parentheses on that, but whatever. Minus 5. That's going to make 5. 5 minus 5 is nothing. -10 spit out. So the coordinates are -1, -10. 15. Costing millions of dollars for a company to manufacture X thousands of automobiles is given by this function, 5x squared minus 20x plus 36. Find the number of automobiles that must be produced to minimize the cost. This parabola here would open up because the 5 out front is positive. And this point right here would be the minimum. And it happens to be at the vertex. So, same formula. The x-coordinate of the vertex is opposite b, in this case a -20, positive 20, over twice a 5. That's 20 over a 10, which is 2. And that's in thousands, right? So 2,000 automobiles minimizes cost of production. And that's what they're going to do, generally speaking. 16, find the zeros. Well, that thing factors. It does, doesn't it? I can pull an x squared. That'll give me an x plus a 4. If you're doing factoring by grouping, x plus 4 has to repeat. And it turns out if you pull a -4 from both pieces of the back of the bus, there she goes. Now you're left with x squared minus 4 times x plus 4. X squared minus 4 factors is x minus 2 times x plus 2, and then you still have x plus 4. So you got 3 zeros. X is 2, -2, -4. Done. 17 is long division, which means I need another piece of paper. Or synthetic. Could do synthetic. I'll do both. Let's do long first. Just because we can. And I'll check my result with synthetic, because I'm far less likely to screw it up. 3m cubed plus 18m squared minus 74m plus 63. To turn an m into a 3m cubed, I multiply by 3m squared. And then I invoke the distributive property. 3m squared times m is 3m cubed. 3m squared times 9 is going to be plus 27m squared. This line is subtracted. 18 minus 27 is negative 9. Bring down a term, minus 74m. And that'll do it. To turn a m into a negative 9m, I multiply by a negative 9m. Sorry, I should have said negative 9m squared. Invoke the distributive property, negative 9m squared minus 81m. Wrap before you subtract. 74 minus a negative 81. Man, I just got wiped out. Should be 7. And then bring down that 63. To turn an m into a 7m, we multiply by 7. 7 times 9, was she 62? That doesn't seem right. 63, right? Yeah, 63. Ah, sweet. 0. That's long division. And it said you could also do synthetic. And you can. You're dividing by this, which means that the m value is negative 9. When we're talking about factors, we always change signs. So I take a negative 9, throw it out front. Coefficients were 3, 18, negative 74, and 63. I'm pretty sure I'm right because I got a 0. Anyways, we drop, we multiply, and we add. We multiply, and then we add. We multiply, and then we add. Now, hopefully you remember that this is the remainder of the constant, the x squared. This is 3x squared minus 9x plus 7, with a remainder still of 0. And that is 17. 18, find a rational 0 of this function and then use it to find all the zeros. We did one of these the other day. Kind of have to guess. First thing we're going to do is we're going to make a list of factors. Or sorry, a list of zeros. It is factors of the constant over the factors of A. This is usually taught factors of P and Q, but I just stick with this because this is what I remember. The constant here is the 14. Takes a 1, a 2, a 7, and a 14. Those are factors of 14. And the constant here is 1, so just plus or minus 1. So when you talk about your list here of zeros you can choose, you can be plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. I'm going to try 2. It's just what I'm going to try. 1, negative 8, 19, negative 14. I drop, I multiply and I get 2. I add and I get negative 6. I multiply and I get negative 12. I add and I get 7. I multiply and get 14, and there we go. Now you can keep playing around with synthetic division all you want, but what you've done is you've pulled one x value from a cubic, and that turns into a quadratic. So let's look at x squared minus 6x plus 7, which is what's left here. That factors. Or, yeah. No, it does not factor. Fudge. That doesn't factor. I wanted it to. Think about it. It doesn't factor. I get to use my good old friend, the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. There we go. All right, so what's a net radical? A net radical is 36 minus 28, which is 8. Seems right. So 6 plus or minus root 8, both pieces over 2. A root 8, you ought to know, is 2 root 2. Like, if you don't, like, how? What's wrong with you? That's 3. 2 root 2 over 2 is just root 2. There's the other two answers. So by guessing and doing synthetic, I found that one. And I found the last two. Third degree polynomial, 3 zeros. Find the domain of the rational function. Really simple thing to do. For 1 over anything at all, the anything must be bigger than 0. So x squared minus 49x must be bigger than 0. I can factor that as x times x minus 49. And this needs to be something you check. You can't just say x is bigger than 0. You have to plot these things on a number line. You have critical values. There's a critical value where x is 0, and there's a critical value where x is 49. But you can't just say, when you're dealing with an inequality, that it looks like that has to be true. At least with a quadratic inequality, it isn't linear. So what I'm going to do is I'm going to test a -1. I'm going to test something in between, which is 1, and then maybe a 50. So if I plug a -1 into this equation right here, I would have a +1 plus 49, which is definitely bigger than 0. So I get to accept all of this territory. If I plug in a 1, I'd have 1 minus 49, which is -48, which fails the test. And if I plug in a 50, I'm going to have 50 squared, which, by the way, is 50 times 50, minus 49 times a 50. And this is just going to end up being 50. I hope you see that, but it ends up being 50. So I get to take all of this. So what did I just learn? I learned that all values of x such that x is less than 0 and greater than 49. Or if I like interval notation, -infinity to 0 unioned with 49 to infinity. The last one I'm going to do for the day, because I'm done doing math and I'm freaking tired. Find the vertical asymptotes, if any, of the graph of the rational functions. Oh, I don't think it has any, to be honest with you. Oh, yes, it does. Vertical asymptotes are formed by factors of the denominator that do not cancel, or that do not cancel out. Good luck reading that. I'm so tired I can't even write. Formed by factors of the denominator that do not cancel out. So factors of 54 that add to 15 are what, 8 and 7? Sounds right. They're both negative because the product has to be positive and the sum has to be negative. So my vertical asymptotes are literally at x equals 8 and x equals 7. Don't you miss the good old days when you could just look at things in a calculator? This is an old calculator, but still, you can still look at it. You know, because I know that seems foreign to some kids, how we can just look at things. This was x minus 64, sitting pretty over, and this is an old calculator, so I have to type it in kind of funny. X to the second minus, I got too many parentheses, minus 15x plus 54, and then zoom 6. Should start seeing some funky things. It actually shows them to you too. Oddly enough, they're not in the same right spot. You know why? Because I'm retarded. Oh, I'm retarded. Good sign. I need to quit doing math right now. That's -9 and -6. 8 times 7 is 42. What kind of drugs am I smoking? 9 and 6. I'm really happy I checked the calculator there. See 9, you can count 6. 1, 2, 3, 4, 5, 6. Really glad I did it. The old 83s actually drew the vertical asymptotes. They did. See, that's an 83. They actually did. Okay, I'm too tired for math. I'm done for now. I'll try and do some more of it another day. Probably Friday.